if I'm doing the square root of x, what value should I use to graph? What would be some nice ones I could use? As opposed to going -2, -1, 0, 1, 2. What number should I use? If I was just plugging in values. 4, 9, 16, etc. Good, Luke. So 0, but use 0 and 1. 0, 1, 4, 9, 16. So use numbers that you can easily square root. Okay, if you don't want to, it's fine. It just makes it easier if you pick numbers that have nice whole numbers as opposed to graphing decimals. Okay, so I'm going to use 0, 1, 4, 9, and 16. Remember the square root function starts at 0, 0, right? So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And the square root of 16 is 4. Is it okay seeing this, guys? Or is that too small? What do the x values say? I can't read. Okay, I'll read this sentence. Oops, the glare out of there. So they're there. So the x values are 0, 1, 4, 9, 16, and then square root each of them. Got it? Okay, next one's a little bit trickier. Yeah, no worries. You're welcome. Okay, so the next one's a little bit trickier because if we substitute, if we use the same numbers, so if I use 0, 1, 4, 9, and 16, actually let me skip to this one. I'm going to skip to the third one first. So I'm going to use the same numbers, 0, 1, 4, 9, and 16. Okay, so I'm using the same one, same numbers, and you're just going to substitute it in. And it's fine if you use decimals here, okay, because we will be graphing, so decimals are fine. So 1 over 3 times 0 is 0, square root of 0 is 0. Didn't I plug in my calculator for this one? Okay, next one is 1 over 3 times 1, which is 1 over 3. So when you square root 1 over 3, you get 0.6 rounded. 0.58, but rounded to 0.6. If I substitute 4, I get 4 divided by 3. I get 1.2 rounded.
Hi, Maria. Can you come to the front to meet a contractor from Fry's? Thank you.
I have 1.7. And then I'll bring the computer closer. 2.3. Sorry, I'm trying to get that glare out of there. So I did the third one. Okay, now we're gonna do the middle one. Okay, so the middle one is a negative 1 over 2x. Okay, so if I'm going to use values, I can't use positive values. Because if I use positive values, a positive times a negative will be a negative. Okay, so when I square root the negative value, it can't happen. Okay, it's not possible. So what I'm going to use is, I'm going to use the opposite of these, and I'm going to do negative values. So I'm going to do 0, -1, -4, -9, and -16. Okay, so we have, get this glare out of there, -16, -9, -4, -1, 0. Okay, so we'll just plug them in, so you get 0 here. I don't know all these ones. I gotta figure it out 1 second, the calculator. .7, 2 square root of 2, 1.4, square root of 4.5, 2.1, and 16, 8, square root of 8. 2.8. Sorry, I can't really zoom in because I need the graph. So those are the values. Let's get this glare out of the way. Should have it blue. -16, 2.8, -9, 2.1, -4, 1.4, -1 and 0.7, and 0, 0. Okay. So lastly, we're going to graph them now. So my x values go from +15 to -16. So let me see. So I'm going to go up by 3s, from 3, 6, 9, 12, and say 15, negative. And 3, 6, 9, 12, 15 this way. And then my y-axis, I only go up to +4. So let's go 1, 2, 3, 4, -1, -2, -3. Actually, I don't have any negative values, so I don't need any negatives.
Changing the stuff on the side. I mean, today for that.
I'm so sorry about that. I was awful this year. Okay, so now we're gonna graph all of them. So 0, 0, 1 and 1, 4 and 2, 9 and 3, and 16 and 4. So it goes something as such as the parent function. Okay, I'm going to do the second one in blue. And my last one. I'll give you guys a minute on that one. I don't know, Declan, when did you, I don't know when you sent that message. I'm just gonna try to have everything in view. Hopefully that helps. Okay, so just want to show again, so we have the k value because it's underneath the square root sign. If it was an a value, it would be outside of the square root function. Why is this all crooked? All right, so here we have our parent function, which is the black one. Then the second table is the blue one. So you'll notice though, it's reflected. So this negative value here causes the reflection over the y-axis. So the blue one is going this way. So instead of going to the right, it is going to the left now because it got reflected. It got reflected over the y-axis. Okay, so that's what the negative value does with the k. If it was an a value, the a value would reflect it this way. Okay, so an a value would reflect it down over the x-axis, whereas a k value, if it's negative, it reflects it over the y-axis. Okay, so the negative causes it to go to the left. And you notice that it's getting stretched now. Okay, so it's the opposite of the a value. So k, if it's between 0 and 1, so it's a half, so that's between 0 and 1, it is now getting stretched horizontally. Okay, so it's getting stretched out, so it's getting lower. Okay, so if we're stretching it horizontally, it's going to become lower. Likewise with our red one now, our last one, again it is getting stretched because it's getting, vertically it's kind of going down, but horizontally it's getting stretched, so it gets thinner. It gets thinner horizontally, so that's what the stretch does. Again, the parent function, and then remember it's the opposite, so this is a negative, so it goes over the y-axis, and then to find the stretch value, you do k divided by a half. So k divided by a half is 2, so it gets stretched by a factor of 2. Over here, this red one gets stretched horizontally by a factor of 1 divided by 0.33, which is 3. So it's always the opposite. Okay, that is the lesson today. Looks like I forgot to put the homework there. So let me double check the homework. Okay, so page 58. Number 1, 2. For A, B. Six CD. Eight and 11. Actually, don't worry about 8. Number 11.
Sure.
Yep.
Could you bring the camera close up to that, please?
So the homework questions?
Yeah, please.